Hello aspirants, so welcome back. I hope the introduction part made things clear to you guys how I am committed towards this mathematics optional. So, as I promised, this is our lecture 1, dear. Also, I asked you guys what topic I should start from. There was class between going from linear algebra to mechanics or some special topics which many aspirants struggle. Taking on account all those confusions, I have decided, because the very much concerning point was कि this means 22 people who are going to write this means, they said, so please try to cover those topics in which we struggle and we can get an A's in this 22 mains only. Keeping in mind all those suggestions or requests, I have decided I will go with 2 topics in one go. Like 3 to 4 lectures will be of the topic which is going to help in this 22 mains only, and one small topic will go in parallel. Like suppose that I have started from the abstract algebra. In parallel, we will be dealing with some small topic, like you can say calculus or this LPP part, for 1 or 2 days in a week. So like this, there will not be much pressure on us. Already I have promised 5 days classes. Even if required, I will take 6 days classes also in a week. No problem. You guys are ready? Okay, it's up to you. So at the top priority, I am focusing on this 22 mains aspirants. Many of those struggled with abstract algebra. Okay, so this is our topic number 1, which we are going to take. Okay, dear. Book is Gallian. Already told you guys, Joseph A. Gallian. See, as far as this topic is concerned, have you ever thought why so many aspirants struggle in it? Why we think this pure mathematics part is not for us, is from engineering background or simple BSc? Why? Maybe it was lack in your undergraduation time studying experiences or the correct source. Acha, one more thing, there is also a good book here in Delhi University. People follow it, R. Kumar, like this. When I was in my ID Delhi days, then people used to take this photocopy of this R. Kumar. Good examples are there, so you can take that also. But go with one book, no issues, either this or that. Okay, I was talking ki why you struggle. I too struggled during my undergraduation, but when I got this book, Gallian, when I analyzed, when I revised and re-revised, I got to know, even I fell in love with abstract algebra, with the group theory part. How? That I'm going to tell you here. See, okay, there may be a introduction where you can start from the number theory as well. People start from the set theory, equivalence relations and all. I will not start from there. Even though I'm telling you, you can start from here. I will start from the group theory itself. Okay, then ring integral domain, field. Okay. I was talking how I fell in love with this topic. Actually, what I found, there are some fixed kind of examples. Like if you talk about group, you will have C, R, Q, Z for the finite part, modulo Zm. You may have general linear group over some field, matrices with non-zero determinant, special linear group, matrices with the determinant value 1. You may have the K-lines 4 group having 4 elements such that 2 elements, those are of order 2 or self-inverse elements. I will talk in detail with some conditions here also. You may have the quaternion group plus minus 1 I plus minus j plus minus k with the extra conditions I into j is equal to minus j into I. Similarly, 3 conditions are also there. A square is minus 1, j square is minus 1, as well as k square. This is the quaternion group Q8. Roots of unity. Wait, I will say, please don't come with a pre-notion or some stereotype in my lecture, because I have developed my own ways. But that I can promise, if you start following this sequence or the way which I am going to teach you, you will be much comfortable with your subject actually. I'm not here just to deliver the knowledge and information and all. I'm just here how to strategize your preparation. How you can strategize your abstract algebra part. So what I told is that there are some standard groups. The whole story will run on and around all such groups. Suppose that you want to study what is inverse. I will take example all of these groups. I will show how you can find inverse. If you want to study subgroup, problem was there in the starting. Although teacher taught you the definition of the subgroup, test, how to check, but you never applied those concepts. You just remembered theorems. You just thought that algebra is all about proving the things only. Theorems. When I changed this mindset, I really got happy actually. So let's say, if anything I got like coset theory. Okay, I will study the definition. What is coset? Coset will be read after the subgroup. So a coset must be a subgroup first. I will look what are the cosets of, suppose that Z8. What are the cosets of the symmetric group Sn or group of permutations? Very famous group, very famous. And we use it multiple times. So what I will do is, I will do all such structures in one go. Repeatedly I will use with each concept. Let's say you want to find normal subgroups. What is normal subgroup? We will deal the theorems part as well. But I will apply those theorems on these structures, on these groups. How it's gonna help you guys? In one way, you will have, okay, I need non-abelian group of order 6. Okay, come, S3. Okay, I need some 8 order abelian group. Okay, come. There is Z8. I need infinite order ka group. Okay, C, R, Q, Z. I want to play with the inverse. Come. SLNF, ZLNF. So all those topics, like you want to know what are the equivalence classes. What are those elements which are conjugate to some particular element of a group, like you can say S4. Give an example of a non-abelian group for which there is some abelian group which is very much known or very much famous example, that is subgroup of that, and that you call alternating group. How smartly you can use that odd or even permutations का group. Will odd permutations will form a group? That is a question mark for you. Let's say you are studying what is possible orders of elements in any particular group. In my BSc, I used to study what is the definition of order of a group, order of an element, how Lagrange theorem work. Although I knew the definition, but I never checked how it will work actually. For that, I have developed this habit. Whatever the definition I will study, I will apply that definition on all these structures. And dear, with this exercise, after 10 to 12 days, you will have on tip all these groups. You getting? And this is really gonna be very beautiful for your study. The same fashion, we will move to rings. Nothing will change there. Only structure will be looking like this. Operation, in place of one operation, there will be two operations. In the same fashion, we will move on linear algebra, that is vector spaces. What is the difference? Difference is group mein you have one set, one operation. Rings, one set, two operations. Vector spaces, two sets, two operations. Ready? How we will move actually. So that is the beauty of following this way of studying. Okay? I hope now you will enjoy. Is that fine? Sure. So let's move on the lecture. Lecture तो चल ही रहा है अभी भी. Starting the lecture. So the topic is algebra. Again, I will say for introduction part, you can read thousands of books, thousands of theories. But here with the UPSC optional, although this year they asked some question from the number theory we will deal. But some extra classes, 1 or 2 classes for that, those will work. Before that, I will start to teach what is group. So group के लिए I will start from the, okay, one thing you can do, although it is a class, just like जैसे कोचिंग में चलता है, still I will say, if you are lazy enough, so you can take screenshots whatever I am writing on the board, or at the same time you can write on your copy whatever like suits you. So before starting group, we need to know what is a binary operation. Bi. Okay? Binary operation on a set G. If you have some set G, let's say G has some elements A1, B1, or you can say A1, A2, A3, and so on. We will say an operation, let's say star, is binary on the set G if on applying this operation between any two elements of the set G, we get some element of the set G only. You getting my point? This is something like chemistry ka lab. What do? One compound, other compound, you mix those two compounds and you get third compound. So if that third compound is of the same family, we will say this mixing the structure is a binary operation on this family. So star is a binary operation on the set G. Achha, one more thing. Every word matters here. A half knowledge is always dangerous in the subject. Whenever you say binary operation, don't call it just like binary operation. Be in the habit binary operation on the set G. So when it is going to be binary on G, if on applying this operation between any two elements of this set G, we get an element in the result, and that element itself must be the element of the set G only. Then we will say this is a binary operation on G. Clear? Now, for example, if I say, let's say G is my set of integers. पूर्णांक संख्याओं का समुच्चय है ना, -3, -2, 1, 0, 1, 2, 3 and all. So if I add any two integers, I will get an integer only. So operation क्या है? This addition. Operation addition is a binary operation on Z. That fine? So in the here, I will just say for you guys, I will all don't use this Z for integers. No, it will be like this: real numbers, natural numbers, complex numbers, set of rationals, set of irrationals. Getting? So this will be looking like this. Sorry. Is that fine? Or you can say matrix addition. If I take, let's say, A1, A2, A3, A4, B1, B2, B3, B4, we get some matrix C1, C2, C4. So matrix addition, let's say M2 by 2 is a collection of all 2 by 2 matrices with entries from real numbers. So matrix addition, don't say addition only, matrix addition is a binary operation on the set of matrices. Getting my point? Is that clear? Similarly, you can talk about C, complex numbers. If you add two complex numbers, then again you get a complex number. So you will say addition is a binary operation on the set of complex numbers. Is that clear? So, okay, I'm in the habit of writing all those marker and duster, na? So, anyways, so binary operation is clear, guys? Okay. Now I move to the other definition, that is algebraic structure. When a binary operation is associated with a set, please note it down, we are on the online platform, so repeating the things like offline is not good, I guess. So please focus on the words. If you miss any word, please go back to the line and listen it again. When I combine some binary operation on the set G, then this is called an algebraic structure. Getting? Chalo. After this, I will start group. An algebraic structure. Please focus on the word algebraic structure means this operation is already binary on the set G, means this is closed operation. On applying this operation between any two elements of this set, we get element of this set only. So this is closed already. Other properties are, because some people write closure axiom, associative, identity, and inverse. Okay, so closure, or you can say binary. Associative means, suppose that you operate that operation between B and C, then with the operation, same operation with some other element you do between A and B, then with the third operation, and result is same, then you say it is associative axiom. Just to lighten note, I will say, suppose that you are going to prepare tea. So some people, मेरे जैसे people, एक ही बार में दूध, चीनी, अदरक जो भी है सब एक ही बार में डाल दिया. Some people think water, then milk, then sugar. Okay, you get some tea. Some people think first water, then sugar, then milk. Ultimately, you are going to get tea, na? So if end result is same, we will say these elements follow associativity. Okay, and these elements are coming from the set G only. And this operation is this star. Okay, not the plus always. It may be any operation. Come with the identity. Please dear, I will deal these two identities separate here just to make it more clear for you guys, because many of us just do rattamar here. I will suggest don't do it, because it is not required. Once you understood it, it becomes easy. See, G with this binary operation satisfies identity axiom if, please note it down, there exists some element in G. Please note it down. There exists an element in G, capital G, such that whenever this element is operated on any element of G, we are going to get the same element. People also read here left identity, right identity as well. I have combined those in one go only. So please, I will repeat. Any algebraic structure is said to be satisfying identity axiom if there exists some element in G. Means G has an element which operated with any other element of the Z or with the same element, we are going to get that element itself. Then we say, so what is dear here target or task? When you say G satisfies, G comma star satisfies identity axiom, if you are able to find such E, please highlight this line. If you are able to find such G, abhi example lenge, it will be more clear. Similarly, I come with the inverse. So I will say this line again. G satisfies inverse axiom if for each, please highlight here, element A of G, there exists some element of G such that A composition B or B composition A gives you the identity. Is it visible? Yes, it is. If you are clear about these definitions, everything is gonna be smooth. Otherwise, you just do rattamar study. If somebody says find the inverse, or you can say that structure satisfies inverse axiom or not. What is your target, dear? For any arbitrary element of G, you just show there exists some element of G with which, if this element is operated, or composition of these two elements will give the identity element. So first we need identity axiom, then we go on the inverse axiom. Somewhere people struggle. First they check inverse. No. Until unless you don't have identity, you cannot go for the inverse. That right? So this is the pattern. I hope all these definitions are clear. If not clear, go back to the lines and listen it again. If some algebraic structure satisfies all those axioms, I will say that algebraic structure is a group. If any of the axiom is not satisfied, any one or more than one, this will not be a group. Is that clear? Fine. Let's move to the examples. We will start from the easy examples. Okay. We'll do smart work here. Let's say I take this real set and the usual addition. Okay? So this is closure, or you can say this is binary on R or not. If you add two real numbers, you are going to get again a real number. So this is binary on R, or you can say R comma plus is closed. Associative. Again, if you add these two real numbers and then add this number, or you add A plus B, then you are going to get the same real number. So R comma plus satisfies associativity. Identity. There exists 0 is a real number or not, such that A plus 0 or 0 plus A is A for all A belongs to R, dear. If 0 is added to any real number, you will get the same real number. So that means this is identity of this algebraic structure. That's fine. Okay. For inverse, let's take an arbitrary element of real number. There exists, and this is non-zero. That is required for multiplication. Minus A belongs to R, such that A plus minus A is going to get 0. If A is a real number, so minus A is also a real number. That means for any real number, you have some real number again, such that if that is composed with the number, you are going to get the identity element only. So what you say is, dear, R comma plus satisfies closure, associative, identity and inverse. So this is a group. One more property you can add, abelian group or commutative group, where A composition B is B composition A for all A comma B belongs to G. This is extra property, you can say fifth property. So if you add two real numbers, 2 plus 3 or 3 plus 2, you are going to get the same result. So you will say R comma plus also satisfies the commutativity. And yes, so R comma plus is a commutative group or abelian. That's fine. Let's move to the other example here. Similarly, you can talk about rationals. Similarly, you can talk about integers. With the addition I have told, you can go with the multiplication also. Fine. Chalo. Okay, if you can go, then tell me. Z with respect to usual multiplication. Please focus on my words. Usual multiplication is a group or not? So if you multiply two integers, you are going to get again an integer. Whatever I am going speaking here, na, you can write on your paper, or if you are going to prove something, you can write the same lines on the paper, and you should write. Without writing, the answer will not be sufficient. So what I am saying, on multiplying two integers, we are going to get an integer. So usual multiplication is a binary operation on set of integers. If you multiply two integers, then with the third, or second and third with the first, you are going to get the same result. So integers follow associativity. Also, such statements you use in your daily life speaking. It must be an integral part of your preparation. Integers follow associativity. Matrices follow associativity. Use like these statements. It is going to help you in all this preparation. Identity. So 0 is an integer, and if 0 is added to any integer, you are going to get the same integer. So yes, there exists some identity element in the set of integers. Is that clear? Chalo. For inverse, 2 belongs to Z. Oh my God. 0 is additive identity, not the multiplicative identity. So multiplicative identity is 1. So flow mein there may be a chance to commit the mistake. Anyways, we are human beings, okay? So 2 belongs to Z. 1 upon 2. If I multiply 2 into 1 upon 2, then only I am going to get 1. So 1 by 2 Z के अंदर है क्या? No, because this is not an integer. So set of integers satisfies closure associative identity, but does not satisfy inverse axiom. So this is not a group. Is that fine? Let's move on. Let's take an example. Z equals 1 minus 1 iota minus iota. Fourth roots of unity. Is it? Chalo. You can take cube roots of unity. 1 omega omega square. By the way, what is omega ka value? Okay. So you have 3 roots, minus 1 by 2 plus iota root 3 by 2 and minus 1 by 2 minus iota root 3 by 2. Is that clear? Again, if you wish, what is z raised to the power n is equal to 1 or nth roots of unity? Yes, I may tell you. Please let me know in the comment box if such equations or such questions you also wish to have. I will detail also. But here I'm dealing group theory only. These are easy ones only. No problem. So just take लिख दो ना cos 0 plus iota sin 0 है ना, और you can say cos 2 pi plus iota sin 2 pi. अब इसका पावर n लगा दोगे, apply the de Moivre's theorem, cos n theta plus iota sin theta, वहां से you can derive all such roots. Okay. Anyways, nth roots of यूनिटी, ठीक है, फॉर्म ए ग्रुप विथ रिस्पेक्ट टू multiplication. This is another example for you. Okay, for example, this is fourth roots of unity, this is cube roots of unity. Okay, one more way we use for this checking all these axioms, that is forming the composition table. So composition table we form for the finite group, that is easy for all finite only. Infinite we cannot form that. Let's say I want to check कि cube roots of unity is the group or not. So 1 into 1 composition करेंगे, 1 into 1, 1 into omega, 1 into omega square, omega into 1, omega into omega square, omega into omega square is omega cube and that is 1. क्यों से? Cube roots of unity. If you cube of this, if you do cube, you will get 1. Omega square, omega cube again 1, and this is omega power 4, that means omega cube into omega. Now this is called composition table. See, if all elements of this composition table are elements of the set itself, we will say this operation is a binary operation on this set G, means this set is closed with respect to this composition. Okay, now there exists an element 1 such that if you multiply 1 with any of other element or the same element, you get the same element itself. 1 into omega, omega only, 1 into omega square. So 1 is the identity element. Getting? Multiplication of these are complex numbers follows associativity. Identity हो गया, closure हो गया, associativity हो गया, inverse. Check it out. For 1, identity, self inverse. For omega, if you multiply omega into omega square, you get omega cube, that is identity. That means omega square is the inverse of omega. और ओमेगा इंटू ओमेगा स्क्वायर क्या बदल जाएगा? वो भी बन रहेगा. So omega square is the inverse of omega and omega is the inverse of omega square. So you can say all elements of this set G has their inverse. Ultimately, all those 4 axioms are satisfied. So this is the group. Not only this is the group, you can go with this, the same composition table, 1 minus 1, iota minus iota, iota square is minus 1. You can show that. Now, you people may think, sir, itna to we have studied in 5-6 lectures. Yeah, I know what you people have done. That is why I already said this is looking like offline class, but not an offline. We have to be smart enough. I'm a mentor, so I know, I understand the importance of time or importance of good strategy. So I'm just here to help you guys. You have one book. Anything you think ना कि टीचर को ये भी पढ़ाना चाहिए था. टीचर थिंक, अभी आप वहां पर जाके देखेंगे सेल्फ इनवर्स क्या होता है, इसका भी डेफिनेशन लिखा है. लेफ्ट इनवर्स क्या होता है, इसका भी लिखा है. If I'm able to make you understand all such stuff, then those definitions will be automatically settled. So following one book with my lecture will complete your preparation. Is that enough? So please follow this lecture series. I'm pretty sure you are going to get good results. Is that fine? In the same fashion, I can go for the symmetric group. Very important example. Although I can take a separate whole 4 hours lecture for this, but I have to finish the syllabus also. So Sn, the first thing I will say, another category of examples of group, symmetric group of permutations. Here we have some words. What is permutation? Permutation is a group of permutations. It 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 is As a teacher, I will say for all of these categories of example, you just remember what is the identity of that set G. So here G is Sn. Okay? We say this is the, we say nahi, this is defined actually, collection of all 1 on 2 functions on the set S equals 1, 2, 3 up to n elements, or this is just n symbols. Don't think these are numbers. You may have symbols like A1, A2, AN. Please focus. Identity, not identity, पहचान वाला. Sn का पहचान क्या है? This is collection of all 1 on 2 functions. This is collection of all 1 on 2 functions. What are those functions? Those are functions on some set of symbols S. So when you talk about Sn, you will have two things. A set of symbols S, and on this set S, we will define all those possible 1 on 2 functions. And at the end, I will take the collection of all these 1 on 2 functions, and this collection of all these 1 on 2 functions on the set S, that is Sn. For example, let's say you have some set 1, 2, 3. So how you can define your functions? 1, 2, 3, 1, 2, 3. 1 ka image 1, 2 ka 2, 3 ka 3. Or you can have some function like 1, 2, 3 to 1, 2, 3. 1 is mapped to 2, 2 is mapped to 1, and 3 on the same. Or you can define a 1 on 2 function on the same set like this. 1 is self-imaged, 2 to 3, and 3 to 2. You can have another 1 on 2 function, 1, 2, 3 to 1, 2, 3, like 1 is imaged 1, or 1 is mapped to 2, 2 is to 3, and 3 is to 1. You can have another function, 1 on 2 function, like 1, 2, 3, 1, 2, 3. So 1 is mapped to 3, 2 is mapped to 1, 3 is mapped to 2. Getting my point or not? You can define another function f6 here also, 1 on 2. Check it out. What is that other possibility? So I have a set S, and I will define a set S3. What it will be called as set of all 1 on 2 functions on a set of symbols with 3 symbols. This will contain all such functions, all those 6 functions which are possible to define, maintaining 1 on 2 on the set S, will be lying between in the set S3. So how it is going to be useful for us? थोड़ा सा सांस ले ले और सोचे इसको. If this confusion is removed, everything is easy. Because people are much confused here only. Now what I am going to do is, I am going to take a composition of function on this set S3. This is composition of functions. Composition of functions means, suppose that f of g of h of x. So this is what? Is it like this? F of x, g of x, h of x. Is it like this? Or what is the difference between this thing? That is homework for you guys. Think about it. Homework. or just 5 minutes break we will take and we will meet again. Okay. So composition of functions, if we define on this set as 3. Okay. Although I can tell, but थोड़ा सा break ले लेते हैं, फिर we will start. Okay. Just 5 minutes break only.